Hello friends, Mr. Burrell here. We're just in the beginning of Unit 2 talking about polynomials. We've already covered a few things about polynomials, some basic things, some terminology with how we identify polynomials, the parts of polynomials, what a polynomial is. So today we're going to move into actually working with these polynomials. We're going to start off by talking about adding polynomials together. This is something that's probably not terribly foreign to you. I think you have covered this before. So this might be a review. If this isn't a review, this will be a good refresher here. So by the end of this video, this lesson, this is what I hope that you are able to do. I hope that you're able to add polynomials together, since that's the title of the lesson, is adding polynomials, and understand that adding two polynomials together results in another polynomial. We'll address that a little bit towards the end. So, I have some terms here on the board that I want you to add together. So, for example, 10 plus 7. What does 10 plus 7 equal? Well, 10 plus 7 is equal to 17. Pretty straightforward. Not too bad, right? 10x plus 7x. What's 10x plus 7x? Well, 10x's plus 7x's is 17x's. Sometimes I have people on here write 17x squared. But no, that is not the case. 10x plus 7x is 17x. What about 10x plus 7? Can I add those together? No, I can't combine those together. Those are not the same. I can't combine something that has x's with something that doesn't. I can't combine those together. So I would just leave it as 10x plus 7. What about 10x plus 7x squared? Can I combine those together? No, I can't. A lot of us are tempted here to say, okay, well, this is 17x cubed. That is not the case. Because these are not exactly the same, those are two different things, I can't add them together. So again, I would just leave it as 10x plus 7x squared. So I put that up because these are some mistakes that I commonly see when people are working with polynomials. So when I'm adding polynomials together, basically we're just combining like terms. That's what we're doing, is we're combining like terms. And what do I say? What do I mean when I say like terms? Well, terms that have the exact same variable and the exact same exponent are like terms. So if I have a term that has the exact same variable and the exact same exponent, those are like terms, and I can add or combine them together. So let me give you this example. I have this big, long polynomial, 5x squared plus 4 plus 2x minus 9 plus 9x squared plus 3x plus 8x cubed. Notice I've highlighted in different colors all the different like terms. So like these two right here would be like terms because they both have the exact same variable, an x, and the exact same exponent, a squared. So those are both x squareds. I could combine them together. Okay? Same here with like my 2x and my 3x. Maybe I'll write a circle around those. My 2x and my 3x, they both have the exact same variable, an x, and the exact same exponent, which in this case is just 1. This is x to the first power. So I can combine those together. 4 and negative 9 here, those are like terms because they don't have a variable or an exponent. So these right here, let me put a triangle around those. Those I could combine together because those are like terms. Those are constants, as we talked about in the last video. Those are constant. Those are numbers without any variables. And then this one right here, 8x cubed, that's the only one of its kind. It's the only term that has an x cubed. So I can't combine that with anything else. So if I were to combine all the like terms together and write this in standard form, I'd write 8x cubed plus 5x squared plus 9x squared is 14x squared. 3x plus 2x is 5x. 4 minus 9 is negative 5. So when I combine like terms, when I add these polynomials together, I get 8x cubed plus 14x squared plus 5x minus 5. Okay? So that's what we're talking about when we're adding polynomials. We're combining like terms. Like terms meaning terms that have the exact same variable and the exact same exponent. Okay, so for example, add the following polynomials. So here I have 7 plus 9. 7 plus 9 is just equal to 16. Here I have 3x plus negative 7x. Well, 3x plus a negative is 3x minus 7x, which is equal to negative 4x. negative 4x squared plus 8x squared. A negative 4 plus a positive 8 is a positive 4x squared. See, the x squared just kind of comes along for the ride. Those are like terms, so the exponent doesn't change. And then 6x cubed plus negative 2x cubed, 6x cubed minus 2x cubed is 4x cubed. So I just combined my like terms there. I combined those terms together. I added them together. So now look at this big polynomial right here. I have 6x cubed minus 4x squared plus 3x plus 7 plus negative 2x cubed plus 8x squared minus 7x plus 9. Okay, so this looks a little bit scarier just because there's more terms, but notice that, like, here's my 6x cubed and my negative 2x cubed, my negative 4x squared and my 8x squared, my 3x and my negative 7x, and my 7 and my 9. I haven't changed anything. I've just taken all these little addition problems and put them into a bigger addition problem. So when I add these polynomials together, 6x cubed and negative 2x cubed, when I combine those together, that's 4x cubed. Negative 4x squared plus 8x squared is a positive 4x squared. 3x minus 7x is negative 4x. And 7 plus 9 is equal to a positive 16. This is cubed. Sorry, my bad. So my final polynomial is 4x cubed plus 4x squared minus 4x plus 16. Okay? So again, all I am doing is combining like terms. I'm putting all the terms that have the same variable and the same exponent together. Okay? Try these. What I want you to do is I want you to pause this video and try some of these on your own. These are in your guided notes. Try some of these on your own, and then we can go over them together. So if you pause this video, we'll go over these together now. So I have x cubed minus 2x squared plus 9x plus negative 7x plus 9. Okay? So I'm going to go ahead and go through. I'm going to identify all my like terms. Is there any other x cubed terms? No, there isn't. So that's just going to be by itself. Are there any other x squared terms? No, there aren't. So those are going to be by themselves as well. Are there any other x terms? Yes, there is. There's a negative 7x. So those I'm going to combine together. Are there any other constant terms, like 9? No, there are not. So that one's going to be by itself. So when I write this in standard form, I'm going to get x cubed minus 2x squared, and then 9x plus a negative 7x, or 9x minus 7x, is a positive 2x, and then plus 9. That is my final answer. X cubed minus 2x squared plus 2x plus 9. Let's look at the next one. I have negative 8x squared plus 3x plus 6 plus negative 2x cubed plus 5x squared plus x minus 4. So let's look here at my x squared terms. Are there any other x squared terms? Yes, there are. I have one over here. So in the end, I'm going to add those together. Are there any other x terms right here? 3x. Yeah, there's one over here. There's a positive 1x. Are there any other constant terms? Yes, it's right over here. I have a negative 4. And the only other term I have is this x cubed term. It's all by itself. I'm not going to be combining it with anything. So writing my answer in standard form, I get negative 2x cubed. Just remember, I'm writing the biggest exponent first. And then my x squareds, I have negative 8x squared plus 5x squared, which is minus 3x squared. Then I have 3x plus 1x, which is a positive 4x. And then I have 6 minus 4, which is a positive 2. So my final answer is negative 2x cubed minus 3x squared plus 4x plus 2. Okay? All right, let's do this last one quickly. Do I have any other x cubed terms? Yes, I do, right here. Do I have any other x squared terms? Yes, I do, right here. I have some x terms in both places here, and I have some constant terms in both places. So combining those together, again, the longer these get, they seem kind of menacing, but they're not very bad. I'm just doing a bunch of little addition and subtraction problems. So 6x cubed minus 4x cubed, this one and this one combined together, is a positive 2x cubed. Negative 2x squared plus 8x squared is a positive 6x squared. Positive 1x and negative 5x. 1x minus 5x is negative 4x. And 3 plus 6 is a positive 9. So my final answer would be 2x cubed plus 6x squared minus 4x plus 9. Okay, so note, when I added all these polynomials together, did I still get a polynomial? So remember the definition of a polynomial. A polynomial is just a bunch of terms that have numbers and variables and exponents combined with addition and subtraction. So when I added, say, these two polynomials together right here in these parentheses, if I added these two polynomials together, did I still get a polynomial? Yes. That may seem like a simple concept, but a little bit later we'll talk about, like in Math 3, you talk about situations where that's not the case. But it's helpful to know that when I add two polynomials together, I still get a polynomial. Just like when I add like two natural numbers together, like this, 2 plus 3, I still get a natural number. Things like that. It's kind of helpful to know some helpful things to kind of recognize. So let's apply what we have just talked about with adding polynomials together to this problem right here. So I have this situation that says the sides of a triangle are represented by the following polynomials. So here's my, say I have this triangle here. It says the sides of this triangle are represented by the following polynomials. 2x squared plus 3, x plus 7, and 3x squared plus 5x. It says write a polynomial to represent the perimeter of the triangle. Well, how do I find the perimeter of an object? What does perimeter mean? Well, perimeter is like the distance all the way around the outside of an object. So the perimeter of the triangle is I'm going to add up all of the sides. So I'm going to have 2x squared plus 3 plus x plus 7 plus 3x squared plus 5x. So I'm just adding all these together. Note I put parentheses around each of those sides. Since this is an addition problem, I don't really need to do that. You can do that if you want to. Some of these parentheses, they're not necessary. But all I'm doing is I'm adding all these polynomials together. So again, I'm going to look and see if I have any like terms. So for example, I have this 2x squared term. Do I have any other x squared terms? I do. Right here, 3x squared. I have this constant term, positive 3. Do I have any other constant terms? Yes, I have a positive 7. Here I have an x. Do I have any other x terms? I do. I have a 5x. So combining these all together, putting them in standard form, if I put together my x squareds, 2x squared plus 3x squared is 5x squared. My x is x plus 5x. 1x plus 5x is a positive 6x. And then 3 plus 7, well, that gives me a positive 10. So the polynomial that would represent the perimeter of this triangle is 5x squared plus 6x plus 10. We'll see some examples like that on your homework and possibly some examples like that on the test. So that's it. That's the end of this video. Hopefully now you feel a little bit more comfortable adding polynomials together. And hopefully you understand that adding, when I add two polynomials together, the result is another polynomial. So that's all I've got for you today. I hope that was helpful. Please reach out to me. Don't hesitate if you have any questions whatsoever. I'd love to help you out. And I hope you enjoyed that as much as I did.